With an ASAP, we can model standard homogeneous materials. We can also model inhomogeneous materials in volumes such as grins or grin fibers. We'll now take a look at tracing rays and defining gradient index systems. A very typical gradient index application is an optical fiber, and some of the capabilities in ASAP are not simply modeling the optical fiber and propagating the wavefront through the optical fiber, but we can also do optical fiber efficiency calculations as well, and that's what we'll do in this example. So let's run the file. So we have 2 grin fibers and a coupler. And what we're going to do is calculate the coupling efficiency by calculating the overlap integral of the system. The energy command in ASAP has a couple option that will do this automatically. Okay, and now for the results. What we can see is the input and the output energy. And here's the output in a color plot at the output of the second fiber. The information we see down in our text output box is the calculated integral value, the fiber coupling efficiency. So within ASAP, not only can we model the optical fiber, which we can see the gradient index properties here, we can easily calculate the fiber coupling efficiency calculation. So in this particular case, rather than simply propagating rays through the system, we're actually propagating a wavefront through the optical system using the wavefront propagation capabilities of ASAP. In addition to optical fibers, many optical systems have lenses made of gradient index materials, and these are a more large-scale version of gradient index. Obviously, the grin fibers tend to be much smaller in diameter. But we also have gradient index lenses, and to define a gradient index material, you'll simply need to define the manufacturer's parameters that describe the properties of that optical material and define a media that then uses those properties. And to propagate through, let's take a look at the results. And what we have is a photographic objective with a single gradient index component in it, this second lens, which you can see as the light curving as the rays propagate through the system. So again, whether you're talking about gradient index fibers where you need to propagate a wavefront, or a gradient index component such as a lens where ray propagation is the appropriate analysis tool, ASAP is fully capable of doing any type of analysis through inhomogeneous materials.